let's say we wanted to choose a board of 3, and you had 3 people. How many ways could you organize that?
Oh, 3.
6. Because you have 3 ways to choose for president, 2 ways for secretary, and then the last person pretty much has to be one up, right? Okay, 3 people to president, secretary, treasurer, but now we have 4 to choose from.
24.
And how'd you get that?
4 times 13.
Excellent. So if you have 21 to choose from,
21 times 20 times 19.
a little louder?
21 times 20 times 19.
Yes. Everybody happy with that? Okay, completing the process, what happened, how many ways can we take 4 and construct a board of president, vice president, secretary, and treasurer? 24, right? 4 ways to choose the president, 3 ways then to choose the vice president, 2 ways to choose the secretary, which leaves the treasurer. There are 24 ways to organize a group of 4 people into a board. How about if we're choosing a board of 4 from 5 people?
5, 4, 3, 2.
Good. And how about we're choosing a board of 4 from 21? Right. Everybody happy with that? Alright, so let's write that down. This is written in the following way. 21, 4, 21 times 20 times 19 times 18. Alright? Now, first things first, let's get to the point of that formula. When you develop a formula, you need something a little neater than that, and we introduce something called the factorial function, which is just n times n minus 1 times n minus 2, all the way down to 2 times 1. And also, by definition, 0 factorial is 1. Now, if we were to make this neat and complete the factorial, so turn this into 21 factorial, what are we missing?
17 factorial.
17 factorial. But you can't go around just multiplying things by 17 factorial. That's frowned upon. And how do you avoid doing that? You're always allowed to multiply by... You're allowed to multiply anything by
1.
1. So we turn this into 1. Right? And so this is 21 factorial over 17 factorial, or 21 factorial over 21 minus 4 factorial. And if you generalize it, that's what this formula is. And that's called a permutation. Every single time you change, the role of each person, you have a different permutation. And it's a long list, right? If you have 21 times 20 times 19 times 18, that's somewhere around 160,000, I think, if I'm doing that correct. So it's a very large number. But, and now we get to that key question. What if we don't care about order? Is it clear to everyone that the same group of 4 is going to show up multiple times in the list of permutations? So just picture these 4. They're going to show up multiple times, right? President, secretary, vice president, treasurer, vice president, president, secretary, treasurer, and so forth, so on, yes? How many times is the same group of 4 going to show up? Much more than 4, because... What's that?
24
times 4?
You said 4 position, right?
Right?
4 times 3 times 2
Right.
times.
1. Right. So it's just 24 times 4, I'm sorry, 4 times 3 times 2. So it's 24. The right answer is 24. Imagine that you literally have these 4 people. How many ways can you organize them? Well, 4 ways. There are 4 ways to choose the president. There's 3 ways to choose the secretary. There are 2 ways to choose the vice president, and therefore 1 way to choose the treasurer. So every single group of 4 is going to show up 24 times in the list of permutations.